when you're talking about, well, let's just start with this. Theoretical versus experimental probabilities. Now, there's a really easy way to know the difference between the two of them outside of getting from a textbook some definition that won't make sense when you read it. Math textbooks, definitions hardly ever make sense when you read it. Theoretical probabilities are probabilities you should get so these are things that we should see happen, and it's what we expect to happen, or even better yet, that's what we can put, we expect it to happen. Experimental probabilities are what you actually get. So if we're running an experiment about flipping a coin, and this is probably the best one. Flip a coin 100 times. What do you expect? Yeah, 50 heads, 50 tails. Is that what you're going to get? Not necessarily. So this is what we call theoretical. And if we, for example, if we ran it and for the number of heads we got 47 and for the number of tails we got 53, this would give us a probability of heads of 0.47, the probability of tails would be 0.53, and that would be our experimental. That's our experimental probability. So basically the difference between the two of them, and it's just a start because I'm just going to throw some basic ideas at you first, and then we're going to kind of break down how we build up these different probabilities and the different parts of the probabilities. We can always calculate the theoretical probabilities based on whatever object we're using. Experimental probabilities can be anything. It could be 99 heads and 1 tail, which is extremely unlikely, but it could happen. But the big thing to start off with is, what's the difference between theoretical and experimental? Theoretical is what should happen. Experimental is what actually does happen. Alright, now some different properties. The sum of all possible outcomes and I forgot to put probability, the sum of all the probabilities of all the possible outcomes. Now, what are the probabilities? Or first off, what's the outcomes for flipping a coin? heads and tails, which has probability of 50-50, right? If you add them up together, it's 100%. So the sum is equal to 100%, or it's equal to 1.0. Because a lot of times we don't use probabilities as percentages. I'll put that in here. We don't use percentages for probabilities because we can't do the math on it. We can't do math on on percentages. We always have to convert percentages back to decimals in order to do this. Now, what's the lowest probability, do you think? Zero. The lowest probability is 0. What do you think the highest is? We'll use decimal places instead of percentages. 1.0. So if we're dealing with probability, we're always going to be dealing with numbers between 0 and 1. So a probability of an event is always going to be between 0 and 1. It could be equal to 0, it could be equal to 1, but it's going to be somewhere there. Doesn't make too much sense to have a negative probability. And a probability of anything over 100%, if it's 100%, it's going to happen. So 110% doesn't make any sense. Just like when you say you're going to give 110%, there's no way that you possibly can give 110%. Because you can give 100%. And that's it. That's all you can give. So when they say, I'm giving 1,000%, my effort is going to be 10 billion%. That doesn't make any sense whatsoever. That's just hyperbole. Now, first off, any questions on kind of the basics? To calculate a probability, the first thing we have to do is calculate a sample space.